We're going to take a look again at the Sierpinski triangle that we were looking at in our last lesson. And last time when we looked at it, we were kind of focusing on fractions and using fractions to help us describe the area of the triangles. This time, we're going to be looking at something a little bit different. We're going to be looking at the number of triangles. So last time we looked at the area of the triangles. This time we're looking at the number of triangles. And we're going to be focusing on exponents while we look at these triangles. And we're going to use what we know about exponents to help us come up with a pattern so that we can predict the number of new triangles at any stage without actually having to count them. So what we're going to do first is step one, we're going to fill out this table down here. So we're going to use tables a lot in this class. And in this case, we have two separate columns. We have the stage and we have the number of new upward pointing triangles. So we're going to look at stages 0 through 4, 0, 1, 2, 3, 4, as we can see up here. And then in each stage, we're going to count the number of new upward pointing triangles. So in stage 0, there's clearly just one. We just have one. And then when we move on to the next stage, to stage 1, what we did yesterday, or whenever you did that last lesson, was we drew in a new downward pointing triangle, and when we put in that new downward pointing triangle, we created 3 new upward pointing triangles. So in stage 1, there is 3 upward pointing triangles. And then when we move on to stage 2, we counted these all out in the last lesson. We figured out that this whole thing over here in stage 1, right, with the 3 upward pointing triangles, that shows up here, here, and here. So that means that there is 3 times 3 upward pointing triangles. And 3 times 3, that's 9. There's 9 triangles there. Okay. And again, in similar thinking, in stage 2, we have 9 upward pointing triangles. And over here in stage 3, that stage 2 triangle shows up 3 separate times, right? 1, 2, 3. And if there's 9 upward pointing triangles in each, that would mean that there's 9 times 1, 2, 3. 9 times 3, that's 27. 27. Okay, so are we seeing the pattern here? Let me see what it is. When we go from stage 0 to stage 1, we go from 1 to 3. And then we go 3 to 9, 9 to 27. What are we doing to these numbers to go from stage to stage? So think about that. Yeah, so what we're doing is we're multiplying it by 3 each time. Multiplying it by 3. What's 27 times 3? 27 times 3 is 81. And if you wanted to go through, you can pause the video and you can count up the triangles in stage 4, and you will find that there are, in fact, 81 triangles. So let's look at this question in step 2. So how does the number of new triangles at each stage compare to the number of new triangles at the previous stage? Well, like I said, we're multiplying by 3 each time. Multiply by 3 each time. So it's 3 times the amount of triangles than at the previous stage. So I'm just going to write multiply by 3 to get to the next stage. So using our answer to step 2, find how many upward pointing triangles are at stages 5, 6, and 7. So what we're going to do, and let's draw in a table. Okay, we've got a table, and we are looking at the stage, and we're looking at the triangles, number of triangles, right? So we're looking at 5, 6, and 7. So if we just have to multiply by 3 to get to the next stage, then stage 5 is going to have 81 times 3, which ends up being, let's pull up our calculator, because that pulling up our calculator, let's see, 81 times 3. 81 times 3, which is 243. And then, again, to get to the next stage, we take the previous answer and multiply it by 3. So 243 divided by 3, which turns out to be 243 times 3 equals 729. And then again, we take the answer from the previous step and we need to multiply it by 3 to get to the next stage. So 729 times 3, that gives us 2,187. And then we can just keep on going from there. However, I have to think that there's an easier way to do this. And I think there must be a way to use exponents to help us. So what I want to do is I'm going to erase some of this, and I want to kind of rewrite our answer. I'm going to use a different color. And what I want to do is I want to write these numbers as fractions. And we're going to start with stage 2. So we said to go from stage to stage, we just need to multiply the previous number by 3. Well, for stage 2, that would mean that this is just 3 times 3, right? And can we write that? With exponents? Can you give that a try? Okay. And then, yeah, so that's 3 squared. 3 squared. Okay, and then 27, well, that was just 9. That's 9 times 3, right? But 9 is the same thing as 3 times 3. So it's actually going to be 3 times 3 times 9. Oop, I'm sorry, 3 times 3 times 3, which, using exponents, becomes 3 cubed, right? And then 81, well, that's 3 times 27, but 27 is 3 times 3 times 3. 3 times 3. So that means that 81 is the same thing as 3 times 3 times 3 times 3, or 3 to the 4th. And we'll see, it just keeps going. So we start with 3 to the 2nd, 3 to the 3rd, 3 to the 4th. You can bet this is going to be 3 to the 5th, 3 to the 6th, 3 to the 7th. Let's just check our answers really quick. Clear? So we're going to do 3. We use this little caret to use an exponent, so that little upward pointing caret, 3 to the 5th. Yeah, that's 243. That's what we were looking for. What about 3 to the 6th? 729, exactly. 3 to the 7th? Yeah, 2,187. So it looks to me like the exponent matches the stage number, right? 6, 6, 5, 5, 4, 4, 3, 3, 2, 2. And what about these ones? What about these ones? So if I follow that same pattern, then this should be 3 to the 1. And 3 to the 1 does equal 3. 3 to the 1, that's just 3 one time. 3 to the 1, that's 3. And then here, this is something, I'm not sure if you've seen this before, but this one, if again we follow the same pattern, then this would be 3 to the 0. 3 to the 0. And this one's kind of a funny thing, but this is a rule of exponents. Anything raised to the 0 always equals 1. So again, this does work out. So that's 3 up to the 0. Okay? And that's 1. So looks like we have found our pattern. And let's just see if we can answer this question. I'm going to leave this one up to you. Explain how you could find the number of upward pointing triangles at stage 15 without counting. So you can go ahead and answer that question. Please feel free to reach out as always.